Hello everyone. In this video I want to show you to connect a passive buzzer and a pressure sensor, but I want to give a little bit more information about the buzzers and the pressure sensors. So first, about the buzzers, there are two major types of buzzers, active and passive. So the active ones, they have an internal oscillator. They can internally make the frequency that you want. All you need to send them is to send them a high or a low voltage, okay? And the sound that they can make is typically a simple beep, so they are really good if you want to create simple alarms or something. That's where they are really good at. On the other hand, passive buzzers, like the one I have over here, these passive buzzers, they do not have an internal oscillator. So in order to control them, you have to send them a PWM signal. And they can create different tones and melodies, and so they can even go and create you simple music as well. So they are a little bit more complicated, but of course you need to send them the PWM signal. Okay, so how do you control a passive buzzer? The command to control it is tone. And as you can see here in this code that I wrote for Arduino, the tone has three inputs: pin, frequency, and duration. So you say which pin with what frequency and for how much of time, okay? So, and you don't need a specific library to include. The tone is a built-in command for Arduino. So, but remember that the job of tone is to send the appropriate frequencies with PWM. On the other hand, for active buzzer, all you need is to connect it to one digital pin, and all you need to send is a digital write or high or low. That's all you need to do. So the active buzzers are easier to work with, and they are a little bit more limited because all they can do is basically a simple beep sound. So what I have here is, as I said, this is a passive buzzer. And the passive buzzers like this, if you look at them close, you can see that there is a plus sign on them. So you need to make sure that one side is basically that the one side that is receiving the pin from the tone command and one of the digital pins, that is the one that is going to the positive end. Okay, and here, that's what you can see. Look at this one here. This blue one is going to pin 8, and you can see that this purple one is actually going to the ground. So all you need to do is to ground one end, the other end you directly send it from a digital pin. Okay, now in some diagrams you might see that there is a resistor between your pin 8 and the positive end of the buzzer. In this case, if you go with a large resistor, the current is not going to be high enough to make the buzz sound. So in this case, I removed that resistor here in between these two. But if you want, you can add a small resistor. If you go with big, the current is not high enough to make this create a sound. Now, on the other hand, we have pressure sensors, and simple pressure sensors. There are two major categories. There are analog ones and there are digital ones. Analog ones like FSR or MPX5010, these are the ones that work based on the change in resistance, and they are very simple. You directly connect them to an analog pin and read a number, typically between 0 to 1023 if they are 10 bits, and you can of course scale them down to any number that you want. The one I have right now, this guy, let me maximize this for you. This one that I have is one of the FRSs. So if you read here, you see it says FSR, sorry, not FRS, FSR. So it's an FSR, and this is clearly an analog one here, right? And FSR stands for force sensitive resistor. So when you apply pressure on it, when the pressure increases, the resistance of that circuit is going to go down. So the voltage, because typically they are attached to a voltage divider, the voltage will change. And if you read it here, let's say via pin A0, which is what I'm doing right now, as you can see with here, then you can of course get different values, different analog inputs, and you can use those to make a decision like I'm doing in my code. Okay, the thing is, typically one of the legs of this resistor, of this force or pressure sensors, goes to the high volt. The other one is going to be attached to the ground and also to the pin that you want to read in the analog value. And between that leg and that pin that you read in, you use a resistor, what we call a pull-down resistor. I have a video separate on pull-down resistors that you can see. So you use a 10K pull-down resistors to avoid reading basically floating numbers with mistake. So this is how you connect them, and you can see that this is the diagram that I have in this case. So you see the buzzer, one end of it, this black line is directly grounded, and the high line is connected to pin 8. And then you see that this basically FSR sensor, you see that one end of it, the red one, is directly connected to high volt 5, and the other one via a 10K basically resistor is connected to pin A0, and the other end of it is grounded. Okay, so that is your circuit that you see here, and as I said, they provide a number from 0 to 1023, and if you want, you can use a map and scale them down. In this case, in my code, I didn't do it, but you can of course map them to, let's say, 0 to 100 or whatever range that you want. And then we of course have digital pressure sensors. Now the digital ones, they are mostly MEMS, microelectromechanical systems, and many of them, they have piezoelectric components to convert basically mechanical deflections into voltages. So inside of them they have silicon diaphragms, and then when you press and deform this diaphragm, the piezoelectric component will convert that or transform that deflection into voltage for you. The good thing about them is most of them, they directly give you the pressure in terms of Pascal. So you don't need to calibrate them and read the number and then try to understand what that number really means to. Because here you see these FSR, like the one I have, they just give you a number. Now that number corresponds to how much Newton or how much pound force. You have to find it, you have to calibrate that. But these guys, they directly give you numbers in Pascal, and they directly give you force per area, which is great. Now when they communicate in SPI or I2C. Some might even communicate in UART. And here I have the circuits and the pin connections for that I'm going to show you. But the good thing is, as I said, they can directly give you the pressure, and not really much of the force is pressure. And the good thing is they can give you either the absolute pressure or the gauge pressure. So they are mostly used for weather and checking the altitude. At what altitude? Because altitude depends on the pressure. So you can check altitudes, you can check weather pressure mostly for them. And these are the ones like BMP 180 or 280. Okay, I don't have one of them right now, but in a future video I might add one of these and show you one of those specific pressure sensors. Right now I have basically this FSR, which you can see here. Now, so I told you that they can give you absolute or gauge pressure, and they communicate by either serial communication, I2C, SPI, or which is synchronous, or with asynchronous, which is UART. And these are the pin diagrams. So if you go with I2C, so this is for I2C, you know that I2C has two pins, the SDA and the clock, right? So the data and the clock. and you can connect them to two of the analog pins of the Arduino. You connect the ground of it to the ground, and you connect the VCC of it to the high voltage of Arduino, and you can communicate I2C. Okay, so this is if you want to do that. If you want to do SPI, in SPI, remember that you had 4 pins, right? So you have the MOSI and MISO, right? Master out, slave in, master in, slave out. You can connect them to two of these digital pins. You have the serial clock that you can connect to another digital pin, and of course you have CS. This, in my previous video, I call it SS, slave select. You connect it to another pin, and then ground to ground and voltage to voltage, VCC to high voltage, and you can do SPI. And if you want to do asynchronous with UART, then remember that UART has TX and RX, the one that sends the data and receives the data. So TX of the Arduino goes to RX of it, which is a digital pin here. You can have a digital pin like D0 for RX, and RX of it goes to another digital pin, which is TX of Arduino, ground to ground, voltage to voltage. And this is how you go with any basically serial communication that are either synchronous or asynchronous. These two are synchronous, this one is asynchronous. I just published a video a few days ago on this topic, and you can learn about it. So now let's go ahead and test this circuit. So here is my code. You see I'm sending the signal out in pin 8, reading the voltage from pin A0 from the pressure sensor. I have 2 thresholds, 5 and 50. If the threshold is bigger than 5 and less than 50, I'm gonna go with a frequency of 1000 hertz, and I can add the duration. So let's say 1 second, right? Or maybe 2 seconds or 5 seconds, something, right? So you have to provide a duration, and let's say 500 milliseconds. And then if it's bigger than 50, I'm gonna go with a much higher frequency, and I'm gonna go with shorter time, right? So you see the duration is in milliseconds, the frequency is in hertz. So I go higher pitch, lower watt duration for bigger pressure, more than 50, and between 5 and 50, lower pitch, higher duration. And if there is nothing like that, so it's less than basically 5, then use the no tone command. That basically doesn't do anything. I put some delay here to stabilize the readings, because I don't want the readings to be super fast. So I'm gonna send this. This is my serial monitor. Also, I'm gonna show the pressure value that I read, right? You see here I'm reading it with analog read. I'm going to show it also on my serial monitor. Good. And you see that when I use the tone, I send it to the buzzer pin. And of course, my communication is in 9600 baud rate, or bit rate is for me 9600. You see, these two numbers should be the same. Otherwise, you're going to get an error. So here, if we go and grab this one and try to put some pressure on it. Okay, let's see. So we just need to go above 5. There we go. Now you see, you hear different sounds, right? So clearly you see sometimes it goes above 5, goes above 50. And you clearly can hear 2 different frequencies and 2 different durations. And all the numbers can be read here on the left side. So here is a simple, basically combination of pressure sense or force sensor and buzzer. Now if you want, you can add several of this, and based on which one you are pressing, you can play a different frequency, and you can make yourself like a mini piano, right? Of course, you don't want to have 88 keys, but maybe like 7 or 8 of them, right? You put 1 octave here, and then click on each one of them. Each one will play 1 frequency, and then the ratio goes according to the piano ratio to the 2 times that, and then you have 1 octave. So if you want, you can have what? You can have a simple piano. I'm sure you can find the examples of that. I guess if you go here to, let me see, to the digital, you see I have tone melody and tone multiple and so on. But this one is with a keyboard, and you can have it, but the keyboard here is actually made of pressure sensors as well. Okay, so here I simplified this for your understanding. I give you a download link under video description, and hopefully you learn how to communicate with a passive buzzer and with FSR. Thank you so much. I'll see you in the next video.